Hi, I am Revathi. I am working as Assistant Professor in SNS College of Engineering in Department of Artificial Intelligence and Data Science. Today we are going to discuss the topic about RAID Level 1. RAID Level 1 means it is mirroring or shadowing. It is also known as disk mirroring. This configuration consists of at least two drives that duplicates the storage of data. It is call it as disk mirroring. This configuration consists of at least two drives that duplicate the storage of data. There is no striping. Read performance is improved since either disk can be read at the same time. Write performance is the same as for single disk storage. Every write is carried out on both disks. If one disk in a pair fails, data still available in the other. Data loss would occur only if a disk fails and its mirror disk also fails. Before the system is repaired, probability of combined event is very small. Pros of RAID level 1: high data redundancy. Provide complete data protection as data is mirrored across multiple drives, ensuring access even if one drive fails. Fast read performance. Since data is readily available on both mirrored drives, read operations can be very fast. Simple to manage. Relatively straightforward to implement and manage compared to other RAID levels. Suitable for critical data. Ideal for applications requiring high data integrity and reliability such as databases or operating systems. Cons of RAID 1: low storage capacity. Due to data mirroring, only half of the total disk space is usable effectively, halving the storage capacity. Potential write performance impact. Writing data to both mirror devices can slightly slow down write operations compared to a single drive. Costly implementation requires twice the number of drives compared to a single setup, increasing the overall cost. Not ideal for large data volumes. Not suitable for applications where large amount of data need to be stored due to the reduced storage capacity. This configuration uses striping across disks, with some disks storing error checking and correcting information. It has no advantage over RAID 3 and is no longer. Each bit of data word is written to a data disk drive. Each data word has its Hamming code ECC word recorded on the ECC disk. On read, the ECC code verifies correct data or correct single disk errors. Advantages of using RAID level 2: extremely high data transfer rates possible. The higher the data rate required, the better the rate of data disk to ECC disk. Disadvantages of RAID level 2: very high ratio of ECC disk to data disk with smaller word sizes. Entry level cost very high, requires very high transfer rate requirement to justify. No commercial implementations exist. RAID level 3: bit interleaved parity check. A single parity bit is enough for error correction, not just deduction, since we know which disk has failed. When writing data, corresponding parity bits must also be computed and returned to a parity bit disk. To recover data in a damaged disk, compute exclusive OR of bits from other disks. Input-output operation addresses all the drives at the same time. RAID 3 cannot overlap input-output. For this reason, RAID 3 is best for a single-user systems with long record applications. The data block is subdivided and written on the data disk. Stripe parity is generated on writes, recorded on the parity disk, and checked on reads. RAID level 3 requires a minimum of 3 drives to implement. Advantages of RAID level 3. Very high read data transfer rate, very high write data transfer rate. Disk failure has an insignificant impact on throughput. Low rate of ECC, that means parity disk to data disk, mean high efficiency. Disadvantages of RAID level 3. Transaction rate equal to that of a single disk drive at best. Controller design is fairly complex, very difficult and resource intensive to do as a software RAID. Thank you.